Now in the last video we looked at the light dependent resistor being used as a voltage divider for an NPN bipolar junction transistor switch. Now we're going to look at the PNP bipolar junction transistor. So you can see the arrows pointing in instead of pointing out. It's a PNP bipolar junction transistor. I use the 2N3906. And so in any case, in this case here, we can just put a light dependent resistor when it's on the high side of the voltage divider there by itself. That's because we will follow the current path here. You can see that when it gets bright enough where it gets close to 0 ohms of resistance, the current path is through that 10 kilo ohm resistor. That's going to limit current, and also it actually turns the transistor off. So there's no base current for the PNP bipolar junction transistor. No current goes that way when the light gets high enough that we pull the base up to 5 volts pretty much. So the only current that will flow through it is through that 10 kilo ohm resistor. It's plenty limited. Now we come to the situation over here. Now we have the light dependent resistor on the low side, and so we're just going to put a basically a minimum resistance you want with 5 volts there, 220 ohms in series with them. So their resistances will add up. And so if it gets bright enough where you get relatively close to 0 ohms, maybe it'll be 50 ohms, 30 or something like that, you can see here that we have a current path from emitter. The arrow points, by the way, with these NPN or these bipolar junction transistors, I mean, both NPN and PNP, the arrow points in the direction of the current flow. So that helps you keep track of that. So in any case, current, a small current going from base to emitter will allow a lot of current going from emitter to collector there for the PNP bipolar junction transistor. But the base to emitter, or emitter to base in this case, doesn't limit current. It takes about 0.6, 0.7 volts before it conducts, but after that it takes something else to limit the current. And so if the light dependent resistor is almost 0 ohms and there's no other resistance to limit it, that would be high current, and you may damage one of the two components right there. So we're just going to put 220 in series to ensure that it doesn't. And then again, with the emitter to collector of the PNP bipolar junction transistor, we have to make sure that it doesn't pass too much current, and so we got a load along the way there. This will set the current once the transistor is conducting fully, because there's enough emitter to base current going to ground. So in any case, hopefully that makes sense. Every once in a while you have a component that under circumstances may have almost no resistance, and that's in light dependent resistor if it gets bright enough. Also, we have a situation where if it gets completely dark, it has hundreds of millions of ohms of resistance. At least the ones that I have do. So this light dependent resistor would be easy to put it into a circuit thinking you're limiting current because it looks like a resistor, but at times it barely has any resistance, and so you're going to need some more in series. Hope that all made sense. Make sure you check out one of the other videos I'm posting on the screen. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. But just watching videos helps out a ton. Thanks to everybody that watches them. I'll see you in the next video.